All right. So make sure I get this set up. So I will go to the R section, but it should be the same for both. I moved so that fourth connect. Oh, where is it at? There it is. I kind of have it so it's factoring into your grade now. You've got those two Excel kind of last connect assignment. If you want to do it, I mentioned if you don't do one of them, right, that would be your lowest and that gets dropped. So if you're happy with your score right now on the connect category, if you don't do the fifth one, it'll just stay the same, right? That'll be the one that gets dropped. Also, so today will be the last day I use iClickers, right? And so early next week, I'll kind of replace your iClicker scores, right? This iClicker category on my grade book off of Canvas. I will drop the three lowest and then kind of get what your iClicker grade is with those three lowest drop up there on Canvas, kind of factoring into your grade. Okay. I'll also, I forgot to mention this in my other section, so you guys get the benefit of me remembering this. I also put up some final exam practice material. So you've got two practice exams, that third formula sheet. Now I also have the third formula sheet, I think just under files somewhere. Yeah, right here, right? And then I also put this figure out your grade tool. So once I have like your iClickers grades updated next week, and you kind of have some idea about where your Connect and Excel grades will be just based off of the current assignments you've turned in. Now, obviously, that could change if you do the remaining assignments and do better, or if you don't do any of them, that could decrease, right? If you've missed a couple. But there you go. Just figure out your grade tool. What you can do is basically plug in whatever your, go into Canvas, see what's my kind of current grade in the Excel category, what's my iClicker grade, what's my Connect grade, and how did I do in the first two exams, right? So you'll just put in your values here. I've got some hypothetical person's values. And then if you plug in different values for the final, it'll kind of give you different predictions for what your grade will be in the class, right? So I always think this is kind of helpful going into finals week. I know if you've got, multiple classes, you might have projects, you might have other finals. And so you can kind of know like, well, how, for this person, right? Maybe it's like, I just want to get a B in the class. How bad can I do? Well, I can do pretty bad. So maybe I kind of put my efforts towards another class where I'm like on the cusp, right, kind of on that cutoff line. Or maybe I really want an A and I say, well, look, I've got to do like really well here. I got to pretty much ace this exam, based on this person's grade in order to get an A. Or maybe I look at this and say, well, based off of my performance on some of the other exams, oops. Oh, sorry, I was messing this one up. I should have been changing this, right? All right, so it's like, oh, I've got to do like really well, right? Like 95 will put me kind of where I might get rounded up to an A, right? So I have that up on Canvas. You can kind of play around with that. If you have any questions on it, feel free to reach out. But I want to try to give you kind of a good idea of what you're going into that final. Okay? Any questions for me before jumping material today?
Where was that
It should be on the files tab. It's so-called like figure out your grade tool.
Which file is it in?
So they're on Canvas. Go to files.
Yeah.
And it's just sitting out there.
But I have to go like the whole file.
Yeah, you can't do it from a web browser. You have to download the file. Any other questions before we jump into material here? Okay, so we left off last class. We were talking about the R squared. I'll kind of revisit this here in a second. But what I want to start out with is we started to look at some examples where I have this difference between causation and correlation. Okay? So one thing when we're looking at these regressions we need to keep in mind is, yeah, I can estimate what these slopes, what these slopes are. I get these slope coefficients. But if I leave out other important variables, right? Like we said, if I had a maternal, whether that the mother smoked and I had birth weights, whether or not the mother smoked is going to pick up a lot of other factors that are correlated with that. Lower income, lower education. And so if I can control for those things, well, now I don't pick up those correlations anymore, right? So I'll come back to this. But basically, if I run this naive regression where I only include this X variable, this first X variable, when I get my coefficient estimate for that slope, it'll pick up the true effect but also this bias component. And it'll pick up the bias of, well, not only am I picking up the effect of this variable x1 I included in the regression, but also the effect of this x variable 2 that I left out, right? Now, as soon as I include that second variable in my regression, I completely eliminate this bias. Okay? So if I have the data, I should be controlling for these other things that I think matter, or that I think would be good predictors of my y variable. And we'll go through an example here in a second in Excel, where we actually have some context to this. But this is the idea that we're not really picking up a causal relationship, because there's always going to be factors, things we don't have data on. And so we need to be careful and say, okay, we still interpret this as the predicted change in y from a 1 unit increase in x, but it's not causal. That's just it's predicted change. It's based off of a correlation, right? So, kind of the idea is that, maybe x isn't causing y, or y isn't causing x. Maybe it's z, right? Something else in the regression that we haven't included, right? That could be driving both of these factors. So I think like day one, I gave the example of, ice cream sales and drowning deaths, right? Well, the thing we're leaving out there is, well, what's the current temperature, right? So we want to be able to control for all these other factors, so we don't have this bias component. So I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe, right? Because maybe it was understanding it was because I had a natural higher intellectual ability, and maybe taking the statistics classes because I had a higher intellectual ability, right? So we want to try to control for these other things that might matter. Another good example of this, if I just looked at like autism rates and organic food sales data, and I ran a very simple linear regression, it would look like increases in organic food sales would predict higher autism rates. I don't think anybody is going to argue that organic food sales, organic food is causing autism, right? It's probably that there's these other factors, like an increased focus on health from the country, that we might see the autism be diagnosed earlier and more accurately, and also people spending more money or buying higher quality foods, right? So it's probably something else, this is Z, that we've left out that's really driving both of these, right? So we've got this bias component. We're going to go through an example in Excel, and I think it's pretty interesting. That really gets at this idea of, if I omit these important variables, my coefficient estimates are going to have this bias built in. I don't want that. So we're going to start out with a very naive regression. And the kind of question, the motivating question here is it a good thing? Oops, I shouldn't say good thing, but can it be beneficial for a college student to be a student athlete, right? So the idea there is, if I'm a student athlete, the argument is maybe it teaches very quickly time management skills. I also have additional resources. Maybe there's team tutors. I have a built-in social network. Like, there's all these things that could be positive for being a student athlete. I also I think maybe I've mentioned this earlier in the semester, but I had like 4 classes with a college, a long snapper on the 2 football team when I was an undergrad. And I had to do some group projects with him, and trying to find a time to meet with him was impossible, right? Like between practices, they'd watch film every day. I don't know how he had time to do anything other than football. And so maybe that has a detrimental effect, right? So we're interested in what this impact is. And our athlete variable is just a 1 if you're an athlete, 0 if you're not. So we talked about last class, I gave you kind of the SAT variable that we interpreted. And so it was always a 1 unit change in our x variable causes the predicted y value to change by whatever our slope is. Well, now my units, right? It's not one more point in the SAT. It's going from the 0 to the 1 group anytime we have what we call dummy variables, right? Or indicator variables. Just a 1 if you're a student athlete, 0 if not. So going from not being a student athlete to being a student athlete, right? Going from the 0 to the 1 group would cause the predicted GPA to change by whatever this coefficient estimate we get is. Okay? So we're going to run this naive regression first. Delay. So, lost my train of thought. Oh, we'll run this naive regression first, but then, what's probably true, if I have Division I kind of college data, what might be true about the admission standards for a student athlete compared to just a regular student at the university? What do you think Alabama football might do? Yeah, they might be willing to accept a lower kind of academic quality student if that student is going to generate a ton of additional revenue, right, for the university. So we know kind of inherently, well, maybe our student athletes have different income and intellectual ability. We don't have a perfect measure of that, but we'll use the SAT scores, right? Now the interpretation becomes, if I go from the 0 to the 1 group, so not being a student athlete to being a student athlete, holding constant the SAT score, now this is a predicted change in GPA, right? So the thought experiment is 2 students with the same SAT score, one of them is a student athlete, what will we predict the change in their GPA to be? So that's what we're going to be doing in Excel. So I think I still have this one pulled up from last class, so I need to go and open the regular file. So we worked a little bit with this last class. And I'll post all the work we do today up on Excel. I'm going to delete the sheet 3 and sheet 2. We're just going to basically recreate these. So here's my data, right? I've got all this college student data. I've got GPAs, SAT scores, all this good stuff. So remember, how do I add in that data analysis? So once you've added in, you shouldn't have to do it again. But if you've got a Mac, you go to the tools and down to kind of manage your Excel add-ins, make sure the analysis tool pack is selected. If you're on a PC, file options, go down to add-ins, manage the add-ins, make sure the tool pack is selected. Once it's selected once, you don't have to do that again. You just go to your data tab and you've got this data analysis option sitting on the right-hand side. Okay. So we're going to open that up, go down to the regression option, hit OK. Our Y variable that we're interested in here, our dependent or our left-hand side variable was, well, what's the student's GPA? So we're going to select the name college GPA, hold Control Shift and hit the down arrow, or Command Shift on a Mac, hit the down arrow. We're then going to go back for our X variable. It's kind of a pain, just scroll up. But we're just going to say, were they a student athlete or not, right? We're going to run this really naive regression, right? So Control Shift, Command Shift on a Mac, hit the down arrow. Now make sure when you're selecting these columns, you're starting where the name of the variable is, right? Now, when we do that, we need to let Excel know I've selected my labels. If I don't, and I hit OK, it's going to yell at me. If I do select the labels, now it can run that regression. We'll kind of zoom in here. All right, we'll go down here. And we've got our intercept coefficient and now our slope coefficient. Right? The way that we interpret this, right? Remember the 1 unit change, since it's a 1-0 variable, is going from the 0 to the 1 group. So being a student athlete relative to not being a student athlete would cause the predicted GPA to go down by 0.28 points. Right? If we're measuring GPA from 0 to 4, that's a pretty sizable decrease. Not only is it a sizable decrease, remember, we always start out assuming that these slopes are equal to 0, or assuming there's no relationship between this X and Y variable. Right? So if we can get a p-value associated with our kind of coefficient or our slope estimate, if that p-value is less than alpha, we always what? Yeah, hopefully this is getting burned into your guys' heads kind of going into this final. Right? So if the p-value is less than alpha, I can reject. If I'm rejecting the null, I'm rejecting that there's no relationship. Said differently, I found evidence of a strong relationship between these two variables. Okay? And you know, the p-value here, e to the -0.9, that means move the decimal 9 places to the left. Anytime you see Excel or output from any other regression or any other data management program, e to the negative means that p-value is pretty much 0. It was so small I had to switch it to scientific notation, right? So anytime you see this e to the negative, reject right away, right? Any questions on this before we kind of keep moving? Kind of getting going here, so stop me if I get it. I like doing this stuff because I think it's the most useful, very useful tool, right? It's the most applicable thing I think you'll probably get from this class, to be completely honest. So we then go back to the data, right? We know this is a naive regression. We said there's probably a bunch of other stuff that matters. In fact, let's just include one more variable, which is what was the kind of best measure we had of that student's academic ability, right? So I'm going to rename this. I'm going to try to rename these as we go through. So this was like our naive regression. So we're going to go back to our data analysis tab. Now, one thing that's nice is whatever you selected before remains in this tool or remains in this regression tool. So I've already got that GPA variable selected as my dependent variable. That's what I still want, right? I'm still trying to predict GPAs. I'm just changing my X variable now to be not only are they a student athlete, but also include that SAT score. Control Shift, Command Shift on a Mac, hit the down arrow. Excuse me. My labels are still selected, hit OK. Zoom in so we can see what we're doing. I always kind of expand this just so we can see some of the names of things here. And if I look at my, got my intercept coefficient, I've got the coefficient on my SAT score variable, and I've got the coefficient on being a student athlete. So now, the interpretation of my coefficient on being a student athlete is if I go from not being a student athlete to being one, right? Go from the 0 to 1 group. Now my predicted GPA only goes down by 0.05, holding constant the person's SAT score. So the reason why that changed so much, right, is we had that bias component built in when we weren't controlling for the SAT score of the individual. Now, the thought experiment, when I say holding everything else constant, here, there's only one other thing, but it's like two people with the same SAT score, but one of them is a student athlete, the other's not. That student athlete, we would predict their GPA is about 0.05 lower. So that, that went from negative 0.28 to negative 0.05. That's a dramatic decrease, right, in the effect of being a student athlete. Not only that, can I say that being a student athlete actually has an impact at our kind of benchmark confidence levels? So if my p-value is 0.26, is that going to be less than any of my benchmark alphas? No, right? So I'm failing to reject at every level. If I'm failing to reject, then what I assume is that there was no relationship. I can't reject that. It doesn't look like there's a strong statistical relationship between these two variables once I include just one additional control. Okay? Now, I still could, I kind of simplified it before when I said there was like this one bias component. There's actually a bunch of different biases for every single variable you leave out that matters. So we eliminated the bias from SAT scores, right? We are now controlling for that. But if there's other variables that matter, that are good at predicting what GPA is, we still have some bias built into our coefficients. So we want to go back to the data and use as much as data as we have, right? And include as many additional controls, things that we think would be good at predicting GPA as humanly possible. Right? Now, before we do that, I want to, oh, never mind, it's right here. So we just found these coefficients. It was like what, 0.68, 0.002, I'm rounding a little bit. And then this one was negative 0.05. So once I have those coefficient values, I can start to come up with predictions, right? Or predicted GPAs for different hypothetical people, right? So for instance, if I wanted to say, okay, what is the predicted GPA of someone who is a student athlete and gets a 1200 on the SAT score? And it's just a pretty basic like linear equation, right? I'll take the intercept. I'll then take, I would add in, but the coefficient's negative. So I'm subtracting the next variable's coefficient times the hypothetical value for that X variable, plus the next variable's coefficient times the hypothetical value for that variable, right? And if I had more, I would just kind of continue that process. So here it's just take my intercept, add to that this SAT score variable times 1200, and then add to that, can't select it because of this thing, so B19, which is where I have that student athlete coefficient. And I said they were a student athlete, so times 1, right? It would be a 1 there if you're a student athlete, 0 if not. Now I can come up with my predicted GPA relatively quickly. So the whole point of kind of what we're doing with regression, like it's good to have these interpretations, these coefficients to understand the relationship between an X and a Y variable, but they're really, really useful at making predictions, right? So you can imagine, like if I had a bunch of historical data, maybe I'm trying to predict something like maybe the direction that stock prices will move for a certain industry, right? Or maybe I'm trying to predict, oh, I did this once in my spare time. I grabbed a bunch of sports data and tried to predict what betting lines would be more likely to hit, right? So you just take historical data and then you use these coefficients, you can make predictions for the future, right? So, I mean, this is pretty powerful. Like, this is kind of a dumb example, but it's not really that dumb, right? If I'm an admissions department and I'm like, well, I need to predict what this student's success will be if we admit them to the university, I might look at all this data and then say, well, yeah, now if I've got the effect of their SAT score, whether or not they're a student athlete, all these other things, maybe actually, come up with some really good predictions and make some better admissions decisions, right? Which the fact that you don't have to submit the SAT score, you'll see in all of our regressions, it's always strongly, I mean, this p-value is like very close to zero, right? There's definitely some predictive power in college GPAs by using SAT scores, but I'm not in the admissions department, so what do I know? So if we go back to the data, we can be even better, right? We can say, okay, let's go back in. We still got the same Y variable that we're trying to predict GPA. Let's select all the control variables that we have. And I'll leave off this squared one. I'll show this to you kind of next week. It's kind of the next level of things I won't expect you to do. It's just in the data set here. So we'll select all the way to high school size. And before we even go, kind of mention this high school size variable is kind of weird. So I can't remember. I was trying to look at these values and think, I don't think it's in the hundreds. These must have, well, probably a lot of small schools. So my guess is like this is hundreds. So like 9.4 would be 940. 1.1 would be 110 people or whatever. So it's kind of a screwy variable, but it's some measure. It's just scaled, right? So we'll kind of select all these variables, Control Shift, Command Shift on a Mac, hit the down arrow. Okay. I'm going to go back, hit OK. And we'll kind of call this one, right? We just threw the kitchen sink at it, right? We took every single variable that we had information on, or every single data point, and we included it as a control variable, okay? So go down here, we'll kind of look at now. Well, now what does it look like, the impact of being a student athlete is? Well, now, being a student athlete relative to not being a student athlete, the predicted GPA actually goes up by about 0.17 or 0.18 points, right? So the reason why it's changed so much is because now the interpretation is that, but holding everything else constant. So the hypothetical kind of thought experiment, and this is what the data allowed us to do by controlling or holding all else constant. Two students went to the same exact high school, size, right? Size-wise. They will have the same total number of credit hours counting towards their college GPA. They have, the same racial demographic, the same kind of gender, right? They're either both female or they're both male. They had the same exact rank in their high school. They had the same exact score on this verbal math test that the university gave incoming students. They had the same exact SAT score, but one of them was a student athlete. We would predict their GPA would be about 0.17 higher. That's a lot more powerful to state, right? As I can control for more things, we do go from being closer to a causal relationship. Now, it's still evidence of a correlation. There's still a lot of other things we might not be accounting for that matter, but we're a lot closer than we were before, right? In fact, if we go back to our naive regression, what's one measure of how much, or kind of how would I want to say this? How reliable our regression results are? Well, how much of the variation in that Y variable are we explaining, right? So we said R squared was this measure of what proportion of the variation in my Y variable am I explaining with all of my X variables? When we started out with this very naive regression, we only had one variable. Being a student athlete only explained 0.008 proportion of the variation in GPAs. That's really, really low. That means 99.2% of the variation I can't explain. That means my predictions using just being a student athlete are probably going to be way off, right? Now, if I then just added one more variable, right, SAT score, what should happen to my R squared? Yeah, I saw someone pointing, right? It should go up. I've got more data, I've got more information, I can make better predictions, right? So now, just including the SAT score variable, I can explain about 16-17% of the variation, or the proportion of variation I'm explaining 0.16 or 0.17. Okay. I sometimes will kind of go back where the R squared is actually shown to us as a proportion. We can kind of convert that to a percentage by simply multiplying by 100. Right? So that's just kind of maybe more generally how we would discuss it, right? As a percent. And then if I throw every single variable at it, my R squared should be even higher, right? So even with all this additional control variables though, you kind of notice like the variation of the existing college GPAs, probably like a lot of other things matter, like what their major is, right? There's a lot of majors that are harder than others. You know, are they working a job at the same time? Like there's a bunch of other stuff that probably matters, which is why even with all these variables, we're still only able to explain about what the proportion of variation we can explain is 0.29 or 29% of the variation in GPAs. So we can still interpret these coefficients, but we should be a little cautious, right? We should remember there's still 70% out there that we can't explain, right? Any questions on the idea of kind of R squared before we kind of continue on to the next thing? Okay with that? Any other questions over want to CSL or anything? Good? Okay. So let's go back to the, actually, no, we won't go back to the data. We'll stay right here. So I already showed you, well, let's also, I'm going to delete these columns. So one thing we won't do, but you could do it with the next level of statistics. If you can do hypothesis testing, you can also do confidence intervals. That's all these columns are there confidence intervals for what that coefficient estimate is. We're not going to use them here just to get them out of the way to clean this up a little bit. I'm going to delete these columns, right? That way we can kind of have everything on one screen, right? And actually, I'm going to now make this a little smaller, and I'm also going to expand these coefficients. So we had an example before where I said we could make predictions for these hypothetical people, right? Now, before we just had two variables, it was kind of easy, right? I could just do this like one simple, all this equation in one cell. What I would do, you don't have to set it up this way, but I just think it's a nice, quick, easy way to do that, no matter what regression output you have, is type in a hypothetical person that you have. So this one, let's say they've got an 1100 SAT score. They were a student athlete. This verbal math test, I think, is measured from 0 to 1. So let's say they got like a 75% basically on it. So 0.75. They were 20th ranked in their high school. Let's say they were male. So this female variable would be 0, right? Let's say that they're white, which would make the black variable 0. Total credit hours, I don't know, 55 is current their credit hours they've taken. And their high school size, 340, which we said this variable was kind of weird. It was like scaled, so that would be 3.4. Okay. So there's this hypothetical person sitting there. What we want to do is go through, take the intercept, and then simply just start adding each coefficient times the hypothetical value for the variable that coefficient is associated with. So for example, I'll go through, take the SAT score coefficient, multiply it by that person's hypothetical SAT score. Then add to that the coefficient on being a student athlete times what their hypothetical value was for being a student athlete. Continue to do that for every single variable, right? And then add them all up. So a nice, easy way to do that is right next to this, I could say, okay, take this coefficient, multiply that by this person's hypothetical value for the variable associated with that slope coefficient. When I copy this down, it just updates it to kind of then go to the next variable's coefficient times that hypothetical value. Now, what do I want to do? Just add them all up. What function could I use here? Just the sum function. Now, what's one thing I forgot here? Yeah, you don't want to forget the intercept, right? So a nice way to do this, you could just add it in at the end, but also if I just extended this column up and I put a hypothetical value of 1, well, the intercept times 1 is just the intercept, right? So that just makes sure that's going to get added in as well. Now, when I go down here, my prediction, I'm just adding up this entire column, right? It's just, like I said, you could do this individually, like click on the coefficient times 1100 plus click on the next coefficient times 1. I just think this is a little bit easier. And also, if I do it this way, so I come up with this prediction pretty quickly, but also I can say, oh, I'm the admissions department, right? I'm trying to predict how successful is this hypothetical student, this person who applied, going to be if I admit them. Well, oh, sorry, we sent over the wrong records. They actually got a 1300 when they took the SAT score the second time, right? Automatically update it. right? You kind of just play around with these values if anything ever changed, or it's like copy and paste each student, right? Here's student one, copy and paste their values in here. Now I can come with their predicted GPA. Go to the next student's application, put their values in, right? So hopefully you can kind of see like the usefulness of this, right? I mean, college applications may not be the most interesting example to you, right? But it matters to someone, right? And whatever you want to do, like I said, predicting stock prices, predicting crop yields, things like that, you know, whatever industry you end up kind of working in, you could just do this just with a different data set. What are questions on this? You want to see a cell again before we keep moving? Okay. So we'll label this coefficients times the X values. And then show you a nice, quick, easy way to make rejection decisions. Okay. So here I'm going to set up an alpha, and I want to be able to say, okay, can I reject the null for each of these variables at the 99% level? So my alpha is 0.01. Well, I know what I should be doing is going through comparing every single variable's p-value, every single slope coefficient's p-value to alpha. If it's less than alpha, I can reject. If not, I fail to reject. But instead of going through this by hand, you can also set this up a lot easier in Excel, right? So what did we use when we were doing hypothesis testing before? The if statement, right? So if, right, I want to check to see if this is true, is my p-value associated with that coefficient less than alpha, comma, if that's true, put the word reject, comma, if it's not, put the word fail to reject. Now, like I said, you can go through and do this by hand individually for each one. I think it'll take a little more time, but also it's easy to make a couple mistakes. The first one being, I see this every single time on the Excel assignment that people do it. If I look at this p-value and say, oh, 6.8 is not less than 0.01, that p-value is not 6.8, right? P-values or probabilities, they have to be between 0 and 1. Oh, it's either negative, that's basically a p-value of 0, right? So it can kind of be easy to make that mistake if you're kind of doing this just eyeballing and kind of doing this by hand. Also, just zeros sometimes, like I don't know, for whatever reason, like 0.002 comparing to 0.01, maybe you think it's higher because you just don't see that there's an extra 0 in there.
What you said earlier, you said if it has an E in it, then it's always reject.
Yeah, because if it's an E, it means move the decimal a bunch of places to the left. So it's going to be really close to 0. It's definitely going to be less than 0.01, right? And so if that's the highest level we ever compare to, we're definitely that we can reject. Does that make sense?
Yeah, that's what I'm about.
Yeah. Any other questions? But yeah, it's a good rule of thumb to remember, right? I don't have to. So if I copy this down, it then updates it to the next coefficient's p-value, but I want to keep that alpha value the same. So I'm going to make sure I freeze that cell reference. Show another.
Yeah. So
Yeah.
With it being known that if it has an E, it's always going to be reject. You like for the Excel assignment, do you still want to show the order? Can you just type in reject?
Like I said, if you want to go through it, like I said, you can just put the rejection decision in there. I think this is just easier because you'll notice I did this one time, right? I get all my rejection decisions very quickly. And I kind of, because Excel will always know if it's less than, this avoids me from making a stupid mistake. Like I said, comparing 0.002 to 0.01 and thinking, oh, 0.02 is greater. And just, for whatever reason, I do that all the time. I mean, it's easy to miss zeros and sometimes, right? First things sometimes. But yeah, you could go through each one and type it out. So, very quickly here we see everything in this regression, we can, except for two variables, which we'll talk about in a second, we can reject the null, or we can reject that there's no relationship, or we found evidence that there is a strong relationship between all these variables that we can reject the null. So the only variables that we didn't really find strong enough evidence to be able to say that there is no relationship would be I think one of the racial demographic identifiers. So race isn't kind of playing a huge role in predicting GPAs. But then also an interesting one would be this verbal math test. Actually, we can't say that it has any predictive power when it comes to predicting GPA. So if I'm the university and I'm giving this to my incoming students, what do you think I probably want to do? get rid of it, right? Why am I wasting time and spending money probably on it when it doesn't have any real predictive power if I can control for all these other factors, right? Once again, our R squared is only 0.3, so maybe we don't completely kick it out, right? But, you know, there's other things that matter. I think it'd be a hard story to tell why, like, things would be operating through the verbal math score, not SAT. So it's like, it's probably that it's not really a good measure, right? And we kind of have now some statistical support behind why, right? Any other questions on this kind of idea of rejection? Okay. All right. So I think that's everything I want to do here. I'm going to save this so I can post it later. Also, I realized this morning I forgot to post the recorded lecture from last class, so I'll get both of those up there today. You guys really don't care as much. But it'll be nice to kind of have this, like if you do want to work on that, if you are working on that 5th Excel assignment, it'll look very similar to what I just did here. Like a lot of the same kind of stuff, making predictions, making rejection decisions, you know, doing a couple steps, starting out with a naive regression, adding in some additional controls. But then we'll also look at another example here today. So this is just what we had in Excel. We already talked about all of this. So we'll work through one more example, which kind of is a little bit different than the one we just did. And I think I might have mentioned this last class, but if not, we'll really kind of hammer this difference. So eventually where we're going to get going, I think is a lot more interesting, but the initial starting question that I'm going to have is spending money on my athletic program going to lead to more success, right? Inherently, we probably know it will, right? So the idea kind of here is, if I were to spend more money on my basketball program, can I change the likelihood that I make it into the NCAA tournament, right? So here we can kind of think about the amount of money being spent or the expenditures on my basketball program. How would that change the predicted value of whether or not I make the tournament? So here where it gets a little bit weird, right? So before, when I was thinking about like increases in GPA, it was like increase in the number of points. Or if I was trying to predict income, it would be the increase in the number of dollars. Well, here, if I have a 1-0 variable for my dependent variable, the interpretation of my coefficient is it's the change in the predicted Y value, or the units of my Y value now you can think of, it's changes in the probability, right? Changes in the probability, I go from the 0 to the 1 group. So when we have a 1-0 dependent variable or Y variable, your coefficients, the interpretation is it's changes in the predicted probability of being in that 1 group. Or here, changes in the predicted probability of making the tournament. Any questions on that idea? So sometimes I'm saying these things like not everything's in the slides. Might be good to like kind of write these things down. You have a 1-0 dependent variable, that coefficient, we still interpret it the same way. It's a 1 unit increase in X, changes my predicted Y value by whatever that coefficient is. It's just like the way we speak, it's changes in the probability now because the units are kind of 0 to 1, right? Probability. So I put round 1 here. This is just like, did you make it in the NCAA tournament? So I think this was before they had like the playing games. I think there was I got the date of the year right before. So just a 1 if you made it into the tournament that year, 0 if not, and then the amount of money you spent in your basketball program. What do you think is probably true about the sign of that beta 1, right? This kind of slope coefficient. It's probably positive, right? I spend more money on my basketball program. I can attract higher quality coaches, athletes, etc. So I probably have increased success, right? Increased probability of making the tournament. What do you think is probably true about the size? Yeah, why? It's 1 unit. It's 1 additional dollar. That's nothing, right? Now it's okay. I can find the effect of $1. And we said, how can I find the effect of, say, spending an additional $1 million? I know the effect of 1. Just multiply by 1 million, right? Just scale it up. Okay. So we know it's probably going to be small and positive, right? We also probably know that if we run a really naive regression like this and we leave out, that's the only control X variable we have, there's probably going to be a lot of other variables we left out that we're going to bias our coefficient. Right? So what are some other things I might want to control for? Well, the first thing I just add in there, It's thinking about, well, maybe the total number of students at the university, somehow kind of trying to control for like the size of the university, right? University of different sizes might have different available funds, and so they could spend more money. So I'll just control for that, and we can kind of see how does that impact my coefficient, right? So we won't talk, don't worry about this. I'm not going to ever kind of make you sign this. This is, I think I used this slide for an additional class as well. That was kind of the next level. Well, you can kind of see if we run this regression, it's showing you slightly different output than Excel. This comes from the data. We get really small coefficients, right? It's the effect of $1. So if I spend one more dollar in my basketball program, probability of making a tournament increases by 0.00000008, right? Really, really small, right? But I would have to scale this up to make more sense, right? I can see programs, and we'll look at it in here in a second, spending an additional $1 million. So even though it's small, notice what's the p-value? Basically 0, which means I erased it, but we can reject that null or reject that there's no relationship. We found strong evidence there's a relationship between the amount of money you spend in your basketball program and its success. That makes sense. You know, you can kind of notice as we add additional controls, right? It looks like the number of undergraduates matters here as well because the p-value is 0. Well, it changes my coefficient a little bit, right? Because I kind of eliminated some of that bias that was built in before by including this additional control. On top of that, how would I interpret my total undergraduates variable here? It would be the effect of one unit change. So having one more enrolled undergraduate would change the predicted probability of making the NCAA tournament by 0.000004. So really small as well, but it is one student, right? And that's like because for each additional student, what's happening to the university's revenue? It's going up by however much they spend on tuition, room and board, all these other things, right? So let's just kind of go to the next kind of level. So we've got this estimate, right, for the effect of one additional dollar spent. So what we could then do is think about, well, what's the range that schools typically spend? I forget what this school that's really low here. I think it'd be, forget if you toss that out, it's a lot, the minimum's not quite that low. But the highest is 23 million. I think this was 2018 data or something. And so it's not, you know, unlikely. I could see the standard deviation is 1.8, so I might see $1 million increases. In fact, what I could do is this thought experiment, something like this. So if I looked at the schools in the top 100, if they increase their budget by 10%, on average, that would be an additional $935,000. So just a 10% increase in their budget, take that $935,000, multiply it by the effect of $1, and you get that if I had a 10% increase in my budget, I could increase the probability of making the tournament by about 0.069 or 6.9%. That might not seem like a ton, but right, that's a pretty sizable increase. And if I can make it into this tournament, there's a lot of additional revenue that can be made. We'll talk about at the end of class, like there might be some other effects that could have. And I could do this for any university, right? So I could do like a 10% increase in IU's budget. That would be 1.2 million. Take the effect of $1, multiply by 1.2. They increase their probability of making the tournament by 0.088. Ball State, 10% increase in their budget, it's only 150,000. They did that 10% increase in their budget, they'd still increase their percent chance of making by about 1%, right? Or the probability of 0.01. You can go through and do this, so you'll just scale it for whatever kind of university you were interested in. So the next step was just throwing a bunch of additional controls in there that was in the data set, right? So kind of start out naive, kind of building up. So I had, did they make the tournament the prior year? How many wins did they have the prior year? Kind of trying to control for their overall quality. What's the revenues, right? Because I can't spend more money if I'm not bringing a bunch of extra money in, so control for that. And then I did this thing called fixed effects, and we'll talk a little bit more about this next week. But basically, oh, sorry. You can kind of think about it, it's like, I just started to include these 1, 0 variables for, was the data from year 2017? If it was, put a 1, if not, put a 0. And then, you know, was the data from the year 2016, right? And basically all this does is it's like holding everything else constant. So it's holding constant the year, which is important if I think that there might be variation year to year in some of the things that are impacting these basketball programs. Right? So it's just an additional control. You don't have to be too concerned with the conceptual side of it. And just know for this, it's going to be an additional control. We'll focus a little more on it next week. So now when I do this, I can see my estimate goes down quite a bit. So this was like 7 e to negative 84, now it's only 2, right? So once I can control for all these other factors, I'm just eliminating more bias, right? And, you know, kind of similar to our last regression, we're right around 30%, right? Our R squared, the portion of variation we can explain and whether or not a team makes a tournament, about, you know, the portion is 0.29, so we're explaining about 29% of that variation. Right? So still got a lot of stuff left that we, you know, we can't account for, right? So we should be a little cautious with these results. Right? However, even when I include all these additional controls, the sign is still the same on that expenditure variable, and the p-value is still really, really small, right? 0.001, I can still reject any of my benchmark values, right? It's gonna be less than an alpha of 0.01. So I know that there's this relationship that exists between basketball expenditures and how successful the program is. Right? If I'm the athletic department, I'm like, give us more money, we might be able to make it turn, right? Why does this matter, right? Or not matter to you, but matters to the university, right? So we won't get through it all today, but we'll just kind of we'll pick up on Monday. The next level is, okay, if I can have more success, and I'll skip this for now, maybe that, you know, people fill out brackets that aren't even interested in NCAA basketball, right? I mean, it's a huge national event. You hear these schools, there's major upsets, it's in the news, even if it's you're not watching like sports networks. And so if you're a small school and you can get into the tournament, and maybe you do get upset, that's a lot of great national exposure. So for instance, you know, what was this? Fair Lake Dickinson, right? I didn't know that was a university before this year until they pull up an upset, and then I saw their name everywhere, right? So maybe someone who lives in, I think they're in New Jersey or something, maybe someone in New Jersey knows about that university, but someone in Indiana probably doesn't. And so if I'm a prospective student, I'm just like, oh, I look up the name, and all of a sudden, you know, maybe they end up having like a really good program or something. Like, for instance, I don't know, those of you from Indiana, like Rose Holman. People in California probably have no idea about it. It has an amazing engineering program, like amazing, right? So just getting your name out there, you might get more people to apply to your university, right? If more people apply to your university, what can you do? Be a little bit pickier, right? Increase the quality of the student you accept. So maybe there's impacts of athletic success on the academic side of the university. So we'll talk about regressions where we can kind of pick up this effect next class. Before you guys get out of here, I also want to mention one more thing. I don't know if I mentioned this earlier. So just respond, any letter. I'll give you 10 out of 10 for showing up today. This is the last time I'll use eye clickers. Did I say this already? Okay, I did? Okay, yeah, so I should after today, early next week, be able to replace your eye clickers, kind of dropping those 3 lowest scores, kind of giving you a better idea about where your grade's going to be going into that final, okay? Any other questions for me before I let you guys get out of here? All right, so just make sure you spawn on the way out. Otherwise, have a fun, safe weekend. I'll see you guys on Monday.